Welcome back. Today, we are going to learn about light and colors. We are going to learn about the history of our understanding of light, dating back from the ancient Greeks all the way up to Albert Einstein. When you think about it, our topic can actually be pretty confusing since we have so much information. So to make it a bit easier, we have created a timeline listing all the relevant people and events that we need to know to fully understand and comprehend our topic being light and colors. On our timeline, we start off with the Greek philosopher Aristotle. Aristotle was part of the trio that are so well known from that time period, being Socrates, Aristotle, and Plato. As well as those three, we also have Euclid. Now, Euclid came along a little later, and although he is very well known as well, he is not considered as one of the boys. Going back to the main big trio, even though the other philosophers came up with many revolutionary ideas, like Plato, who came up with the theory that everything is made of a mixture of the four elements, fire, water, earth, and air, and that there are only four main colors, one for each element, red, white, black, and yellow. Aristotle, however, was the only one of them to actually address light. He came up with the theory that the essence of light is white light, and that colors are made up of a mixture of lightness and darkness. Now, this theory fits with Plato's theory. Euclid was the one who brought geometry into the equation, and many consider him the father of geometry. He used many different tests to determine that light traveled in straight lines. He also was the first person to describe the reflection of light. The next person on our timeline is Sir Isaac Newton, who in 1666 conducted what is generally called the prism experiment. Before Newton, Aristotle's theory was considered correct. But when Newton took a look at printed books from far away, it is reported, he thought that they looked more grey than black, and therefore decided to commit a series of experiments. The way his experiment was set up was that he took a completely dark room and allowed a small circle of light to come in through a glass prism, and it hit a piece of white paper. Then he observed. The effect was that an oblong circle of light appeared on the paper, looking a lot like a deformed sun, and although it was a white colour in the middle, it had a blue and a red tinted area on each end, disproving Aristotle. He again repeated this experiment, but with a rectangle instead, and managed to create the multicoloured band that we all know today. Using these experiments, he concluded that there were 7 main colours: red, orange, yellow, green, blue, indigo, and violet. He later published his findings about the whole thing in the book Optics, which was published in 1704. Next, we have Ole Rømer, who was a Danish physicist who, in 1676, got an idea. It occurred to him that light, like anything else on the planet, must have a finite speed. He proved this fact in the same year, however. He did not prove which speed it travelled at, but he paved the way for further studies into this area by other scientists. James Maxwell was a Scottish physicist who found 4 equations that linked the concepts of electromagnetism to the concepts of light. These equations are pretty complicated, so we won't go into details right now, but the point is that he proved that electromagnetic waves and waves of light travel at the same speed. This was a leap in our understanding of the way light travels, since there had been done a lot more research in the field of electromagnetism than there had been done in the field of light. There was a lot of inaccuracy and speculation as to whether light was particles or waves, until 1905 when Einstein came along and helped with the understanding of photons. He came upon the concept photoelectric effect, meaning the emission of electrons when light hits or is shone on an object. This gave us the understanding of photons and what they really were. From this we learned photons carried no mass, they didn't carry a charge, they traveled at the speed of light, and we got a definition as to what photons were, namely a particle representing quantum of light or other electromagnetic radiation. Here we have Ernest Rutherford. He came up with the model of atom, where it was believed that electrons would continuously emit photons, meaning the electrons would spiral and end up in the nucleus. But if Rutherford had been right,
there would be no atoms at all because, well, they would eat themselves. Niels Bohr then modified this model to look like the one we know today. Here the electrons are like planets orbiting around the Sun, the nucleus. The planets will only be in the orbits with the same amount of energy. The further away the planet is from the Sun, the more energy it contains. Sometimes, these things called quantum leaps happen, where one planet suddenly gets energy from outside. This is called a photon of light. This makes the planet super excited and makes it jump from its original orbit to an orbit with more energy. But at one point, the planet calms down and ends up falling back to its original orbit. When this happens, it produces light, and depending on the amount of energy it drops, it has a specific color. So, today we have learned about the history of our understanding of light, Bohr's model, and we now know what a photon is. We hope that you enjoyed the video and that you found it useful.